Welcome to Train Signal. You're watching a video about network devices. In this video, we are going to go over some of the more common networking devices that you'll find on today's networks. So the first thing we need to take a look at is we need to take a look at connectivity. Right? How are we going to get computers connected to a network? And a couple of devices I have listed here are a modem and a NIC, or network interface card. Now, a modem is something that is mostly considered a device of the past. And the reason why is because modems are used for dial-up connections over standard analog telephone lines. So a modem will give you a maximum of 56K or 56 kilobit of throughput, which by today's standards, where everybody has high-speed internet, it's pretty slow. Now, a modem could be integrated onto a system motherboard, and many of today's computers, I'm sure you will find, still have an RJ11 telephone jack in the back. And that's usually coming from an integrated modem chip on the motherboard. But it also could be an internal expansion card that you put inside a computer, or it could be an external peripheral device. A network interface card is what is more commonly used today to connect your systems to physical network media. And they too can be integrated onto a system's motherboard, where you'll just have, well, typically I would say an RJ45 jack, and that would be for Ethernet cabling, but technically you could have either fiber or coaxial network cards laying around, and those would have different types of jacks. But the most typical card that you'll find is one with an RJ41 jack, either coming off of a chip on a system's motherboard or from an internal expansion card, as I have pictured here. Now, before we talk about any other devices, I want to point out that these devices don't necessarily have a specific look to them. That is one of the big mistakes that a lot of people make, especially people who are new to networking and they're trying to learn this. And that is that you try to picture what a device looks like. And there is no one look to a device. A device very often, and we'll just start right at the top here with a repeater. A repeater could be a box, kind of like what I have illustrated right here. Or it could be a computer. Or it could be, and this is kind of confusing, but almost like software within a computer. There are many different looks to what these devices can be. So don't try to picture the actual device itself. I want you focusing on what the functionality is of each of these next few devices. Now, speaking of a repeater is used to help deal with something called attenuation. And that is a word that was brought up back when we were looking at our cabling video, because all network signals will deteriorate eventually if they have to travel too far, and that's called attenuation. So a repeater is nothing more than a device that takes a signal in on one port and retransmits it out the other. So in other words, if these two computers, so if this computer here wants to communicate with this computer over here, but this computer's too far away to receive that successful transmission, well, then we have to implement a repeater so that the computer can send it, and the repeater will hear the signal, and then it will retransmit it again so that it can make it the rest of the way to the receiving computer. Now, I will tell you that a repeater functions at the physical layer, or layer 1 of the OSI model. And you may remember that from the OSI video that I had a repeater listed down at the physical layer. It has no special functionality other than to hear a signal and repeat it. Now, a hub is basically a multi-port repeater. The hub will take a signal in on one port and forward it on to all other ports. Okay, so a hub, once again, functions at layer 1, or the physical layer of the OSI model, because all it's going to do is take a signal that has been transmitted to it by one computer and then send that signal or repeat that signal out to all other computers that are connected to it. Again, no real sophistication to it. It hears something and it retransmits it or repeats it. But in the case of a hub, it's connecting multiple computers. Another common place where you would see a hub, just going back to stuff that we've already talked about, would be when working with the star topology. When you have a physical star topology on your network, well, that central connection point to the star is generally a hub. Now, if we move up one layer in our OSI model, moving up to the data link layer, or layer 2 of the OSI model, we'll find our bridges and switches. A bridge is a device that has a very simplistic routing table based upon MAC addresses, the physical hardware addresses of the network cards. Bridges are used to create what's called separate collision domains. Now, this is a term that you're going to want to be familiar with. Matter of fact, there's a couple of terms you're going to want to be familiar with. And one is collision domain and one is broadcast domain. And they are kind of what they sound like. We learned with Ethernet that all the computers have simultaneous access to the network, and when they communicate, we can have collisions. Well, if we were to go back, let me go back a step here to our hub, I would tell you that this altogether would be one collision domain. Okay, a collision could happen anywhere on this particular network because if two or more computers transmit simultaneously, those transmissions will collide. Whereas here with a bridge, what will happen is that we have one collision domain over here and another collision domain over here. Because what happens is when a computer sends out a transmission, it goes out along the cable in both directions. And when it gets to the bridge is able to look at what, again, is a very simplistic routing table. This would just basically be a routing table that says these 4 computers are on this side and these 4 computers are on this side. That's all it knows. But if it gets a transmission that is designated for one of these 4 computers, then it passes the transmission through. If it gets a transmission that is designated for one of these 4 computers, well, then it stops the transmission there. For that reason, only communications within this area can collide, and only transmissions within this area can collide, therefore separating this into 2 separate collision domains. Now, as long as I mentioned it, I will tell you there's another term called broadcast domain. Let me clear all this mess out of here. What a broadcast domain is well, it's just that. It's a domain in which broadcasts can be communicated. And I will tell you that if one computer here were to send out a broadcast communication, because it is destined for everybody, the bridge will pass that broadcast through, and therefore this is all one broadcast domain. And if we go back to the hub, well, this too would be one broadcast domain. Now, a switch is basically a multi-port bridge. What switches do is they make a network much more efficient by making each computer that is connected to it its own collision domain, which means it can only collide with itself, which is kind of ridiculous. And very often, I'll tell you what, if you have a switch and a hub, and like I said, I don't want you actually trying to picture what these things look like, but I will tell you that if you have an actual switch and an actual hub and you put them side by side, and you don't look at any of the words, you just look at the boxes, they'll look very similar because they both have a bunch of ports and have a bunch of computers that can connect to those ports. But what happens in the scenario I have drawn out here is you'll notice that we actually have a hub that is connected to one of the ports of the switch. And what that means is that all of these computers are all on one collision domain. But then each of these individual computers that are connected directly to the switch, they are all part of their own collision domain. And the reason why is because when one computer sends a transmission into the switch will look at its routing table. And again, it's a very simplistic routing table, and I don't mean to keep emphasizing that to you, but I need to, because a router, which we'll get to in just a moment, also has a routing table, but it's a much more sophisticated routing table. This is a very basic routing table that just has the MAC addresses. This switch knows the MAC address of each of these 4 computers. And actually, really, it has the MAC address of all 8 of these computers, if you include the 4 that are down here. But what it has in its table is that each of these 4 individual ones will go out this port, go out this port, go out this port, go out this port, and any of these 4 all go out this port. And so what that means is, if I clear my mess out of here, if a computer sends in a transmission, it will look and it says, oh, that transmission was only meant for this guy. So there really can't be any additional collisions because the transmissions are going directly from the one individual sender to the one individual recipient. Now, a moment ago, I mentioned the term router. As a matter of fact, I've mentioned the term router a couple of times throughout different videos. And as a matter of fact, a couple of videos ago, I actually put up a big long definition of a router. And we talked a little bit about what a router generally does. And that's the same thing we have here. Routers are used to connect networks together, right? We learned that when we learned about subnetting. Routers will connect different networks together. Routers, unlike bridges and switches, have sophisticated routing tables which can determine the best route to get information from one network to another. And what I mean by that is that if we have a network that has multiple routers and many different networks, the router is capable of doing more than just routing between one side or the other. A router might know how to get from one network through another network to another router to another network to another router, we could say, to another network to another router to another network, which finally has the computer we're trying to get to. Okay, so routers can have very sophisticated routing tables, which I will tell you function at layer 3, which is the network layer of the OSI model. And the one extra piece of information I want to share with you right now is that routers are used to create separate broadcast domains. Okay, so there's that term I said would be coming up again. So if we look at the diagram I have here, well, you'll notice that here I have a hub with a bunch of computers connected. So this right here is a collision domain. On this side, I have a switch that has 4 individual computers connected to it. So each one of these circles that I'm making is its own collision domain. Okay, so that's just collision domains. But as far as broadcast domains are concerned, this side is one broadcast domain and this side is another broadcast domain. And the reason why is because routers do not pass broadcasts. They only pass through direct communications in which they have a specific destination address. Now, I don't want you to worry too much more about routers right now. We're going to get into much more detail about routers and routing in a later video. But I want you to understand the basic concept is a router is going to connect multiple networks together. It uses IP addresses in its routing table, functioning at layer 3, network layer of the OSI model. And it is used to create separate broadcast domains, meaning routers do not pass broadcasts. Now, if we can take a step back for just a moment, I want to talk to you about switches. Because when we talk about a switch, it can get really, really confusing. And the reason why is because the switch that I described to you a couple of pages ago is the original concept of a switch. But what has happened since the switch was originally created is people have come up with newer functionality that you can associate with switches. And I will tell you that many of today's switches aren't switches at all. Matter of fact, they tend to be multi-function devices. In other words, they will act as a switch, but they might also act as a router. And some of that takes us into what I have here, which is the multi-layer switch, which could also be kind of looked at as a multifunctional device. Does function at the data link layer of the OSI model like a regular switch, but also provides additional functionality at higher OSI layers. Now we're going to look at some of that functionality in just a moment, but that's what we mean by multi-layer switch. Or if you see a switch that you want to purchase and it says it's a multi-layer switch, that's what they mean. Okay, maybe this switch functions at level 2 and at level 3 of the OSI model. Now, a content switch is another fancy type of switch, and again, it's essentially a content switch is also a multi-layer switch to some degree. They tend to be very expensive. You don't see them a whole lot, but it's a type of switch that will actually inspect the data, and based upon what type of data it is or what type of content it is, it can be programmed to send that request onto different ports, which would then in turn get you to different servers. Now, I've also seen a content switch used for the purposes of clustering, which is something we're not going to get into here, but clustering is the concept of having more than one server, more than one physical server, acting as a single logical entity to a client, to an end user. An end user just wants to be able to access just this one server as far as they're concerned, but one physical server may not be able to handle the load, and or you may want to have fault tolerance in case that one server goes down. So you have multiple servers, and then the content switch can actually divvy up that load. That's another definition of a content switch. Now, continuing along the lines of switches not just being switches, I will tell you that there are switches that now give something called power over Ethernet, which is where we actually can send electrical power across standard twisted pair cable. So certain smaller devices can be powered by just being plugged into a switch via standard twisted pair or standard Ethernet twisted pair cable without having to have a power source of its own. We also see this in things like USB ports and FireWire ports. Okay, but here, when it comes to networking, we're talking about over twisted pair cable. Now, something else that a switch can do is, I mentioned that switches have very simplistic routing tables. So what can happen is there may end up being a situation where there are multiple routes that can be taken to get to a specific node on a network. And so there is something called the spanning tree algorithm that switches used to then figure out which is the best route. Now, I will tell you that this does not turn a switch into a router. Matter of fact, none of these things truly turn a switch into a router, because if that were the case, well, why would we even have routers? It just gets you closer to being like a router. Now, another thing that switches can do, and this is very popular in today's networks, is switches can create what's called virtual LANs or VLANs. And VLANs are created in order to emulate multiple broadcast domains. So what you're doing is, instead of physically dividing into different broadcast domains via a router, you can actually be connected all into one switch and then have that switch logically say, okay, we're going to kind of add a little routing functionality into this and truly divide this into two different broadcast domains. And along with that, the computers that are on these, let's say, two different broadcast domains on a single switch would likewise be part of separate subnets with regards to their IP addresses. So what do we mean there? We mean that it's a layer 3 switch, which means that it's a switch acting more like a router. Now, trunking is something that a switch will do when it needs to present the configuration of more than one VLAN, more than one virtual LAN, over a single connection to another switch or router. Okay, so it's trunking. It's kind of like bringing it down to, you might have heard of a trunk line before. It's like trunking it into one line. Port mirroring is something that a switch can do if you want to send a copy of network data to a second connection or a second port off of the switch. And this is usually done for the purposes of monitoring, meaning all the data that gets sent to one place, we want it to be sent to another place simultaneously. And the first place it was being sent to was, well, that's where it was really meant to be, right? That's where the destination of the data was supposed to go. Whereas the mirrored connection, the second port it goes out, is to another system which is doing nothing but monitoring the network. That's the most typical way that port mirroring is used. And then port authentication is used to restrict access based upon authentication information. And I've written here that it's typically used in what's called an 802.1x network. And that's, again, not something we're going to get into right now. But that is another thing that switches can help you with, is if you are going to implement an 802.1x authentication network, which is a very secure network. There are switches that are designed to function within these types of networks that will provide authentication services so as to validate what computer is actually transmitting and then deciding whether that computer is allowed to transmit through the switch. So, as you can see, switches are quite the confusing animal these days. Not only are there many different shapes and colors and sizes and everything else to physically trying to picture what a switch looks like, but then also there's a lot of different functionality to what a switch does. So when you go out looking for your network devices, you need to make sure that you never walk into a place and say, I need a switch, because you may not get exactly what it is that you're looking for. Now, if we move along from here, here's a couple of security-related devices that we have. One is a firewall, and firewalls are used to protect private networks from external intrusions. Firewalls control what data is allowed in or out, so it controls both inbound and outbound data to or from a network. Now again, just like I mentioned with the other devices, don't try to picture what a firewall looks like. I can tell you that I don't know that I've ever seen an actual network firewall that looks like this. That is kind of a universal drawing of what a firewall looks like. But firewalls can be not only hardware devices, but can also be done through software within an operating system. Now, a proxy server is something that serves three main purposes. One is to disguise an end user, so within your internal network, disguise the end user or client computer's actual identity using NAT. Network Address Translation, which we spoke about in a previous video. So a proxy server is also a NAT server. But as I mentioned in that other video, and I'll mention again now, a proxy server also can cache requests to save bandwidth. Meaning if you have one internal client who requests content from a certain website, and then you have a second client who makes the same request within a reasonable time frame, then the proxy server can go ahead and reply to that request without ever having to go out to the internet. And then the third function is that a proxy server can control content permitted to be requested from the internet. In other words, you can put in filtering that says, I'm not going to let my users make requests to go to pornographic sites because they're not appropriate for the workplace. Unless, of course, you work for a pornographic company. But anyway, you get the idea, is you can control what websites they can actually make requests to get content from. Now, the next device I have here is something called a wireless access point, or a WAP. And a wireless access point believe it or not, it's basically the same thing as a hub. But you'll notice from the picture that I have here, and this is just an illustration, this is not an actual wireless access point. You'll notice, well, there's no ports, right? On the hub that we had, well, there were all kinds of ports that you could connect into. Well, the reason why is because all the different connections are being made via the airwaves, not via a physical cable. And so really what we could picture this as is if we take this wireless access point and we draw a bunch of lines going off like this, well, those lines could each represent a connection that is coming in from a wireless client. And that is how it works like a hub. Now, we will talk more about wireless access points in another video when we talk about wireless networking. Now, here we have what's called a basic DHCP server. And here's the thing. A DHCP server is a DHCP server. So what makes it basic? Well, first of all, DHCP is a TCP/IP service, as we learned about in a previous video, that is used to dynamically assign IP addresses on a network. And the DHCP server is responsible for managing the pool of IP addresses that are available to be used on the network. Some devices, certain switches, routers, etc., will have basic DHCP server functionality built into them. One of the most common places we see this is if you take a look at a cable modem or DSL router. Okay, if you have either cable service or DSL service coming into your home or your office, and you then want to expand that out to multiple computers, you go out and you get a little, it's called a router, which is kind of interesting that it's called a router because it tends to also be very often a wireless access point if you are setting up wireless in the location. But even without wireless, it also very often will have a number of physical ports on it. And those ports generally, not always, but generally will act like a switch. Sometimes they act like a hub, but usually more like a switch. And it only really acts as a router going between the switched network, where all the ports go in and or the wireless comes in, and then the one port that goes out to your cable modem or DSL modem. Well, one of the things that these particular routers do is they have DHCP server functionality built into them so that your internal computers on your home network or business network can get IP addresses. Now, the reason we say basic functionality is because there are other DHCP servers which have extensive functionality where you can hand out not just IP addresses, but all kinds of different configuration information related to TCP/IP. Now, what I also have on this page is something called a DNS server. And quite frankly, I probably could have put basic DNS server as well because it's a lot like DHCP. DNS is also a TCP/IP service which is used to resolve host names to IP addresses. And the DNS server is responsible for maintaining the hierarchical directory of names, and I should say names and IP addresses, in a database which respond to clients' requests for name resolution. So when you're sitting at a computer and you say, I want to go to trainsignal.com, your computer will then go to a DNS server to find out what IP address trainsignal.com is. Well, again, some network devices, and I could use the exact same example, your cable modem or DSL router, will have basic DNS functionality built into them. And then also, certain operating systems, like Microsoft Server operating systems, will have extensive DNS server capabilities where you can do all kinds of stuff with all sorts of different types of DNS records, meaning instead of just name to IP address lookup, you might also be able to recognize a computer that provides a certain service, or possibly you might locate an email server, which has a separate type of record. And then you also can have a hierarchy of DNS servers, etc., etc. I don't want to get too deep into this, but you need to understand the basic functionality of a DNS server, and then also understand that certain networking devices are going to have DNS functionality built into them. All right, next we move into something called a CSU-DSU. And I will tell you that although they don't all look exactly the same, this is something that is an actual physical device. Okay, there isn't a whole lot of differentiation when it comes to a CSU DSU. This is a very specific device which converts data frames used on your local area network into the data frames used on a wide area network. And then, of course, the other way around. And where you typically will find a CSU DSU is when you have a T1 line, or maybe a T3 line. But when you have a T1 line, you will have a CSU DSU connecting that T1. It'll actually terminate the T1 line, and then will begin your internal network. All right, next we have media converters. And a media converter, well, it is pretty much what it sounds like. It's used to convert from one form of media to another. So it converts between different types of media, thus the name media converter. Now, media converters come in all sorts of different shapes and sizes, but the most typical use in today's networks would be to convert between your twisted pair copper cabling and your fiber optic cabling. And why is that the most common? Well, because those are the two most common forms of cable that are currently in use. Now, if we go back a page here, you might remember the CSU DSU we were just talking about, and some people refer to this as being a form of media converter. And the reason why is because it's a box that has a couple of ports on it, and on one port it's going to connect to an external T1 line, which is using one form of media, and then the other port's going to be connected typically to twisted pair Ethernet cabling, which is a different form of media, thereby making it a media converter. Now here I have a picture of a media converter which would be used to convert between twisted pair and fiber optic cabling. And as you can see, here there's an RJ45 jack which would be used for our 10100 Ethernet connection. And then over here we have a couple of fiber optic connections for our fiber optic network. So you would use this form of a box if you had part of a network on twisted pair and then had a different part, or maybe even a backbone, that was on fiber. Now the last thing we have here is a couple of things called load balancer and bandwidth shaper. And both of them are devices that are designed to help make networks more efficient. Load balancing is the concept of divvying up the load between different areas. I mentioned something called clustering when I was talking about multiple servers so that we could have fault tolerance. Well, another form of clustering is load balancing, where you have more than one server servicing the clients, and then you balance the load between them. Well, when it comes to networking, a load balancer is used when there's more than one line of communication available, and the balancer will divide that communication between the different communication lines. So as a for instance, you may have maybe a cable modem line coming in, and then maybe you also have a DSL line coming in. I actually worked in an office where we had that exact situation. And then a load balancer will go ahead and make it that some of the requests to get out to the internet will go out the cable modem, and some will go out the DSL line. So that's what a load balancer does. It balances the load. Now a bandwidth shaper is the same thing in the sense that it's trying to make communication more efficient, but now you have a much higher level of control over specifically what data is going where and when. You can use a bandwidth shaper to limit the amount of data that goes through a certain connection during certain hours of the day, hold that information, send it off at a later time of the day. You can have much more control. Sometimes it's called even bandwidth throttling, where you can actually control specifically how much bandwidth is used for certain types of data on a certain line. Now again, one thing I'll mention is both load balancers and bandwidth shapers, don't try to picture what they look like, because they don't look like anything. Matter of fact, very often they're done through software. They are also hardware, but very often it's done through software. So don't worry about what they look like. Alright, so that's a number of the networking devices that we're going to look at for right now. And at this point, after watching this video, you should be able to describe some of the various network devices that you'll see on today's network and know when to use them. So that's all I got for you. I'll see you in the next video.